Nobody likes to see this under a vehicle, but the fact of the matter is, sometimes leaks do develop. As a service technician, it's our job to determine the source of the leak and repair it. But at times, this isn't as easy as it sounds. Leaks can occur when gaskets harden and crack, when seals wear, when fasteners work loose, or when components become worn or damaged. Hello, and welcome to MasterTech. This month our subject is engine oil and transmission fluid leaks. The purpose of this month's program is to examine the diagnostic procedures that are necessary to identify and to locate the source of engine oil leaks and transmission fluid leaks. Before we start looking at leaks, let's discuss the effects of incorrect engine oil and transmission fluid levels. In this first segment, we're going to review the importance of maintaining correct levels of engine oil and transmission fluid. After watching it, you should be able to explain what can happen as a result of an insufficient supply of engine oil or transmission fluid. Likewise, you'll be able to describe what can happen when there's too much engine oil or transmission fluid. Any time a vehicle is driven with too little or too much engine oil or transmission fluid, a number of things can go wrong. For instance, too little engine oil will lead to internal engine problems. This is because the oil can't circulate properly through the engine's lubrication system. As a result, internal engine components are subjected to increased friction and heat. If a vehicle is driven for an extended period of time, accelerated engine wear or damage could result. If a vehicle is operated for long with low engine oil levels, you'll probably begin to hear noises from inside the engine. You may hear a tapping or a clatter coming from the valve train. Sometimes low oil will result in connecting rod or main bearing rapping or knocking. Like engine oil, maintaining the right level of transmission fluid is important for overall performance. If a vehicle is driven when the transmission fluid level is low, you may begin to notice a delayed engagement when the transmission is placed in reverse or drive. On the other hand, the result could be a harsh engagement of gears when in reverse or drive. As with engine oil, when a vehicle is driven for prolonged periods with insufficient transmission fluid, internal components that are normally lubricated can rub together, which again can cause accelerated wear or damage. This can also create noises from inside the transmission. If the fluid level is too low, the transmission could fail to engage at all. As always, any time that you need to add or replace fluids, be sure that you're using the correct amount and type. For engine oil replacement and specifications, refer to the appropriate service information. Likewise, refer to the appropriate service information for transmission fluid replacement and specifications. Also, take care not to overfill the engine or the transmission. As with low levels, high levels of engine oil or transmission fluid can cause their share of trouble. An engine with too much oil can exhibit the same valve train noise that low oil levels can produce. When the engine has too much oil, aerated oil can enter the lifters and cause them to become spongy or sloppy. Too much oil can also cause oil to leak from otherwise good seals or gaskets. If the transmission has too much fluid, delayed or erratic shifting can result. And like engines, too much transmission fluid can cause leaks. As you can see, maintaining proper fluid levels is important to overall vehicle performance. When checking the level of the transmission fluid, remember that there are a number of things that you need to do first in order to ensure an accurate reading. The vehicle should be at normal operating temperature. Make sure that the vehicle is positioned on a level surface. Run the engine at curb idle speed and give the fluid time to drain down. With the parking brake set, shift the transmission through all the gears and then back to neutral. If you perform these steps, you'll be sure to get an accurate transmission fluid level reading. Before we begin diagnosing engine oil and transmission fluid leaks, let's try a review question. After you hear the question, you may want to stop the tape to discuss the answer, as well as some of the other material that we've covered. Technician A says that the transmission fluid level should be checked at normal operating temperature. Technician B says that the transmission fluid level should only be checked with the engine off. Who is correct? A, Technician A, B, Technician B, C, both A and B, or D, neither A nor B? The correct answer is A. When checking the transmission fluid level, the engine should be running at curb idle speed and the vehicle should be at normal operating temperature. In addition, the vehicle should always be positioned on a level surface with the parking brake set and the transmission in neutral. In this next segment, we're going to look at how to diagnose external leaks. After watching this part of the program, you should be able to distinguish an oil leak from a transmission fluid leak. You'll also be able to explain the causes of engine oil and transmission fluid leaks. By using readily available tools and procedures, you'll be able to determine the source of an external leak. Let's begin by taking a look at this vehicle that was brought into the dealership with a possible leak. Hey, Chris.
Hey, Tom.
Chris is new around here, so we're going to give him a quick review on leak detection. You ready?
Yep, I think I'm all ready.
Now, as with any diagnosis, where do we want to start?
That's an easy one. First, we want to start with the 6-step troubleshooting procedure.
That's right. The 6-step troubleshooting procedure gives us a step-by-step approach that will help us through any diagnosis that we need to perform. First, we'll verify the complaint. In this case, we can see that there is some type of fluid dripping under the vehicle. So we know that a leak does exist. Now what, Chris?
We want to find out where it's coming from?
Well, not quite yet. Before we look for the leak, we want to determine what type of fluid is leaking, whether it's engine oil, transmission fluid, and so forth. This way we won't waste our time looking in the wrong area of the vehicle. You can start by checking the work order for any mention of fluid level history. If the customer has constantly topped off a specific fluid, it may be noted there.
Well, I guess this is the part of the diagnosis that corresponds with the second step of the 6-step troubleshooting procedure.
That's right. The second step instructs us to verify the related symptoms. And the third step tells us to analyze the symptoms, which is what we'll do next by analyzing the fluid we've discovered. Sometimes you can identify the fluid that's leaking by its color. But remember that you can't always depend on it as a positive ID. For example, the engine oil is usually amber or black, while automatic transmission fluid is red or brownish red.
Well, why can't we depend on color comparison?
Well, for two reasons. First, some fluids can become discolored with age and vehicle mileage, making it hard to determine what their original color was. Also, many of the fluids that are used from vehicle to vehicle are the same color, or pretty close, making it difficult to distinguish one from another. For example, engine oil is amber, but so is power steering fluid, while automatic transmission fluid is red, and manual transmission fluid is brownish red. Obviously, the location of the leak on the vehicle can help to narrow down the type of fluid, but not all of the time. If you aren't sure what the fluid is by looking at it, try smelling it. Engine oil has almost no odor, while automatic transmission fluid has a slight odor.
Well, what if I have a cold and I can't smell a thing?
Well, that wouldn't be a problem. Another way to identify the leaking fluid is to check the viscosity. Compare this sample of the fluid that is leaked out to this new automatic transmission fluid.
Transmission fluid feels thinner.
Okay, then try this engine oil.
This feels the same.
Which leads us to believe in this case the leak is engine oil. Engine oil has a thicker viscosity than automatic transmission fluid. If the fluid had been thicker than the engine oil, then we'd know that it was manual transmission fluid.
Well, what's this brown fluid?
That's gear and axle lubricant, which is used in a differential in a 42LE transaxle. The 42LE is a dual sump transaxle. Automatic transmission fluid is used in the transmission, and gear and axle lubricant is used in the differential. Routine maintenance includes inspecting the differential area for leaks. A fill plug on the side of the transaxle is used to check the fluid level, and for adding fluid if necessary. If you notice any differential fluid buildup near the differential vent, you'll want to refer to a recently published TSB, which addresses issues concerning an auxiliary vent tube assembly that has been released, which provides improved differential case venting. Once we know the type of leak we're dealing with, we need to isolate the cause of the leak, which is step 4 of the 6-step troubleshooting procedure. Isolating the cause of the leak can be a little tricky, since where you see the leak isn't necessarily where the leak originates. So where do you think we should begin, Chris?
Well, do we start at the top and work our way down?
Exactly. Since the leak will flow to the lowest point of the vehicle, you always want to start at the highest point and work your way down. When you come across either an engine oil leak or a transmission fluid leak, a number of conditions could be causing it, including misaligned or deteriorated gaskets, seals that have been damaged or deteriorated, fasteners or parts that have worked loose, broken parts, or porous castings. Since the fluid that is leaking in our case is engine oil, we want to begin in the engine compartment, again starting at the top of the engine and working our way down. The checkpoints that we'll be looking at today apply to the 4.7-liter engine used in the Grand Cherokee. Obviously, the checkpoints will vary according to the vehicle and engine that is exhibiting the leak. For this reason, refer to the appropriate service procedures when checking for leaks. First, we want to inspect the area around the oil filler cap for oil seepage. Here, it's clean, but if oil was present, we'd know that either the filler cap was loose or the seal was bad. Next, check the area around the PCV hose at the filler tube. If the O-ring on the PCV valve was bad, oil could find its way out at this point. Check for leaks around the cylinder head covers. Oil seen here would indicate a weak seal. Inspect for leaks at the oil-filled tube attaching point, at the timing chain guide access plugs, and at the camshaft position sensor seal. Finally, look for the absence of dirt on engine components. Areas on the engine that are cleaner may have been washed clean by dripping oil.
Well, that didn't take us very long.
Actually, this is just an underhood inspection. Let's go ahead and raise the vehicle so that we can take a closer look underneath. Our inspection of the engine compartment didn't reveal the source of the leak, so now we're going to look under the engine to see if we can find any leaks here. We'll begin by checking the sealing between the cylinder heads and the block. Next, to make sure that the gasket for the timing chain cover is sealing properly, we'll inspect the area around the cover for signs of oil, and check for leaks around the oil gallery plugs. Look for oil around the crankshaft front oil seal area. If there was evidence of oil, the seal may need to be replaced.
Which isn't a simple task, right?
It may take a little bit of time, but having the right tools and following the appropriate service procedures will help.
Well, what else should we check?
Next, we'll inspect the oil pressure sending unit, or switch, depending on the vehicle, for evidence of oil. Then check the area around the oil filter. If the filter seal was bad, or the filter was loose, you'd see oil here. We want to look for leaks around the crankshaft position sensor. If the seal was bad, oil would be visible. On engines that are a bed plate design, check for oil between the bed plate and cylinder block mating surfaces. And check the rear oil seal area for evidence of leaks. Finally, check the seal around the oil pan and the drain plug. At this point, our diagnosis hasn't led us to any evidence of a leak. In a minute, I'll show you a dye test that we can perform to help pinpoint the leak source. But while we're here, let's go over what you need to look for if the leak had been transmission fluid. For the transmission, we'll modify our top-to-bottom approach slightly, in that we'll cover upper checkpoints left side, followed by upper checkpoints right side, and then lower checkpoints. As with engines, your checkpoints will vary according to vehicle and transmission usage. On the left side of the transmission, check for leaks around the input speed sensor, the output speed sensor, the manual lever shaft, and the 23-way connector. On the right side of the transmission, check cooler outlet and inlet ports and lines. Check the area around the line pressure sensor for fluid. and check for fluid around the fill tube connection at the case. At the bottom of the transmission, check the area around the oil pan for leaks or loose bolts. Check for oil around the area where the transfer case mounts to the transmission. Finally, follow both oil cooler lines forward to the radiator, looking for evidence of leaks.
Well, is that it?
Almost. On vehicles with the 42LE transaxle, you'll need to inspect the weep hole for oil, which indicates that the transfer shaft seal for either the transmission or the differential is leaking. If oil is present at the weep hole, the transaxle will have to be removed and the faulty transfer shaft seal replaced. You'll want to refer to the appropriate service procedures to do this.
Which can be found on the MDS2, right?
Correct. But the information is also available in the appropriate service manual. Well, we've done a complete visual inspection and haven't yet been able to identify the leak source. As I mentioned earlier, there is a dye test that can be performed to help locate leaks that are difficult to diagnose. Leak detection dyes can be used to pinpoint gasoline engine oil leaks, diesel engine oil leaks, automatic and manual transmission and transaxle fluid leaks, transfer case leaks, AC refrigerant leaks, and coolant system leaks. A number of approved leak detection dyes are available through Mopar Parts, Pentastar Service Equipment, and SPX Miller Special Tools. Just be sure you choose the correct dye for the leak you're checking for. Now we'll add the specified amount of soluble dye to the oil. Then we'll start the engine and run it for about 15 minutes. This allows the dye time to mix with the oil. After 15 minutes, using the ultraviolet light, we'll check the dipstick for the dye to make sure that the dye is mixed with the oil. To make this easier, we'll use these dye-enhancing glasses that are available through Pentastar Service Equipment. Since we see dye on the dipstick, we can begin to search for traces of it on the engine. Using the ultraviolet light, inspect the engine area for signs of the dye. As with our visual inspection, we want to begin at the top of the engine and work our way down. If you're unsuccessful in finding traces of the dye, you can take the vehicle out for a road test, which will help the dye to leak out, and then repeat the inspection. If the dye test reveals the location of the leak, refer to the appropriate service procedures to make your repairs. As I mentioned earlier, the same test can be performed to locate a transmission fluid leak. Repeat the steps, adding the specified dye to the transmission fluid. But this time, shift through all the gears before inspecting for the leak.
Well, what if we still can't find the leak using the dye test?
Well, for an engine oil leak, there's still one more test that you can perform. An air test, which involves manually pressurizing the engine crankcase. To do this, disconnect all crankcase breathers and plug them. Then attach an air hose with a pressure gauge and regulator to the oil dipstick tube. Gradually apply air pressure from 1 to 2.5 psi while applying soapy water at the suspected leak source. If bubbles appear, you know you've pinpointed the leak. When applying the air pressure, be careful not to exceed 3 psi, or you could damage seals or gaskets. If you suspect that the leak is coming from either the rear seal or the torque converter housing, refer to the appropriate service procedures for repair information. Well, that just about covers our external leak diagnosis.
Yeah, I didn't realize that looking for engine oil and transmission fluid leaks was so involved.
Well, there is a lot to remember, but as long as you do it in a systematic process, it isn't too difficult. Before we continue, let's try another review question. Again, it's a good idea to stop the video to discuss the answer. When diagnosing engine oil or transmission fluid leaks, what is the first thing you should do? A, a dye test. B, a visual inspection. C, an air test. Or D, none of the above. The correct answer is B. When diagnosing an engine oil or transmission fluid leak, first perform a thorough visual inspection. In this segment, we're going to take a brief look at diagnosing internal engine oil and transmission fluid leaks. After watching it, you'll be able to recognize the signs of an internal engine oil leak and the signs of an internal transmission fluid leak. You'll also be able to describe the procedures used to isolate the cause of an internal engine oil leak and an internal transmission fluid leak. An internal engine oil leak can be identified by hard black deposits on one or more of the spark plugs. The information on the work order will probably indicate that the vehicle is consuming oil with no evidence of a leak. This internal oil consumption can occur as a result of oil entering the combustion chambers. Some possible causes of this are worn rings, worn cylinders, leaking valve guides or valve stem seals, or a malfunction in a positive crankcase ventilation system.
Well, what's the best way of isolating the problem inside the engine without tearing it down?
By performing a cylinder compression pressure test. To perform the compression test, you'll need a DRB3 and PEP module, adapter number 8116, and a transducer. The transducer plugs into channel 1 of the PEP module, and the adapter attaches to the transducer. If you don't have the DRB3 readily available, this test can also be performed using the compression gauge. Before you can perform the compression test, the vehicle has to meet some minimum criteria. Make sure the engine has the proper level of engine oil and is at normal operating temperature. Make sure the battery is completely charged and the starter motor is in good operating condition. To perform the test, follow the steps in the appropriate service procedures and compare your readings with those listed in the engine compression specifications. If your results indicate low engine compression, then you know that there's a problem within the cylinder.
Which involves more troubleshooting, right?
Right. For instance, to determine whether the problem lies with the valves or the rings, you can perform a wet compression test, which involves squirting a small amount of engine oil into the cylinder that has a low pressure reading. If rings are the problem, the oil should seal the cylinder and raise the reading. Anytime a vehicle is exhibiting shifting problems, there could be a leak inside the transmission. The service procedures contain information that can help you isolate internal leakage, such as examination of hydraulic pressure and clutch volume indexes. Keep in mind that hydraulic procedures can be performed with the DRB3's PEP module and the appropriate transducers and pressure test port fittings. The PEP module has to be calibrated first. To do this, refer to this month's reference book for further details. In some cases, the DRB3 can indicate hydraulic pressure, which it obtains from the TCM's pressure transducer. Results of these hydraulic procedures can reveal the cause of most transmission or transaxle problems. For example, on electronically controlled transaxles, low pressure in all positions can mean a defective pump, clogged filter, or a sticky pressure regulator valve. After you've pinpointed the source of the leak, you'll need to perform the repair, which is step 5 of the 6-step troubleshooting procedure. To make the necessary repairs, refer to the appropriate service procedures. And finally, after you've made the repairs, verify that the repair is a success, as summed up in step 6 of the 6-step troubleshooting procedure. In a minute, we're going to look at sealers and gaskets. But first, let's try another review question to see what you've learned. As always, stop the video after hearing the question to discuss the answer.
Oh, hey Tom.
Yes, Chris?
I think I have a good question for them.
Go ahead.
Thanks. Which of the following conditions is most likely to lead to internal engine oil consumption? A. Loose fasteners. B. A loose oil gallery plug. C. Worn rings. Or D. Porous castings. The answer is C. Internal oil consumption can occur as a result of oil entering the combustion chambers. Some possible causes of this are worn rings, worn cylinders, or leaking valve stem seals.
Good question, Chris.
Thanks.
In this last segment, we're going to look at common sealing methods and components that are used in most engines and transmissions. After watching, you should be able to describe various ways of sealing components with seals, gaskets, and sealants. You'll also be able to demonstrate an understanding of the proper ways to prepare sealing surfaces during service.
When servicing seals or gaskets, if they're in good condition, do we still need to replace them?
Not always. Sometimes they can be reused. If you're uncertain about seal or gasket reusability, the applicable service procedure can give you more information. Seals are used throughout the engine and transmission to help prevent components from leaking. Like seals, gaskets help to prevent components from leaking. Gaskets can be found in a transmission oil pan, transmission oil pump, and engine oil pan, to name a few locations. Various sealants and lubricants are used with seals and gaskets to help fill sealing surfaces. Chris, do you know the difference between aerobic sealants and anaerobic sealants?
No. Does it have anything to do with air, though?
It sure does. Aerobic sealers use the moisture in the air to help the material cure, while anaerobic sealers will cure in the absence of air when squeezed between two surfaces. Mopar gasket maker is an anaerobic sealant, which is used when assembling metal-to-metal components, like engine core plugs and the engine oil pump. 2 and 2.4 liter engines are a bed plate design and use Mopar bed plate sealant. This anaerobic sealant is used between the bed plate and cylinder block. The 4.7 liter engine is also bed plate design. However, it uses Mopar engine RTV Gen 2. This is an aerobic sealant which can also be used in place of gaskets. It's also used to seal components that are exposed to engine oil. Automatic transmission RTV bonds aluminum and steel, among other things. When applying automatic transmission RTV, be sure not to use an excessive amount, as uncured RTV will cause the transmission fluid to foam. You should refer to the appropriate service procedure for proper usage. TSB number 210599 involves using a reusable gasket in place of RTV on vehicles with the 41 TE/AE transaxle, so you may want to refer to that. Finally, Mopar gasket sealant is a slow-drying aerobic sealer used to seal threaded fittings and gaskets against oil. Before you install any seals or gaskets, it's important that you clean and prepare the sealing surfaces properly in order to ensure a reliable seal. When removing old gasket material, especially on aluminum surfaces, there are a couple of tools that you should avoid using. Never use a metal scraper or a wire brush on any gasket sealing surface, or damage could result. Whenever necessary, use a plastic or wood scraper and gasket remover solvent, being careful not to gouge or scratch the sealing surfaces. You can use a cleaner such as Mopar brake and parts cleaner. You want to make sure that the surface is smooth and clean, free of oil and dirt. Also, be sure that you're using a lint-free shop towel. For more information about cleaning aluminum sealing surfaces, refer to the 1999 March MasterTech program, which covered head gasket service. Well, that wraps up our discussion of oil and fluid leak detection. Before we leave, how about one last review question? And don't forget to stop the video to discuss the answer.
As well as all the other information that was covered.
Right. Which of the following sealers is aerobic? A. Mopar engine RTV Gen 2. B. Mopar gasket maker. C. Mopar bed plate sealant. Or D. None of the above. The correct answer is A. Mopar engine RTV Gen 2 is an aerobic sealant that is sometimes used in place of gaskets. Well, Chris, did you learn anything new today?
Yeah, I did. Matter of fact, I think I'm ready to tackle that Grand Cherokee.
Good. You should be aware of service equipment and special tools available through SPX Miller Special Tools or the Pentastar Service Equipment Catalog that can help you in diagnosing and testing for leaks. Also, additional training is available. Refer to the 1999 Core Curriculum Course Catalog. Thanks for watching this month. Join us again next month when we'll update you on the PCI bus.